So the recording has started. Avishek, you can go ahead now.
Okay, thanks, Mike. So, first of all, guys, sorry, I'm on a mobile network. I have a power cut since morning in my place, so I cannot really run on my Wi-Fi. So, you may have some lags while I'm speaking and sharing my screen. By the way, I think all of you can see my screen, right?
Yes,
Guys, can you
Abhishek.
hear me?
Yeah,
Yes,
we
please.
Yeah, sure. Okay, okay. So, serverless, or like, what is serverless basically? And how many of you are using serverless? I mean, I know the Technogist folks are already using it. Like I've seen Nina has joined, so I know they're already using it. But the outside folks like Sovan or Ionkar, are you guys using it?
yeah. So serverless means
Okay.
which has a computing power. Basically, we don't have any physical
Mm-hmm.
machine. We have a computing power to compute anything on the cloud. So
Mm-hmm.
that is serverless.
So why do we need such kind of ecosystem? What is the advantage of that? What is the disadvantage? Have you ever thought of that? So.
So I can see one advantage like we don't have to manage the servers on the premises. So it will be managed by somehow by the cloud provider. There are many cloud providers. So
Mm-hmm.
they are responsible to manage those servers. We are not responsible for that, basically.
Mm-hmm. Yep, that's another thing actually. So let's do a deeper dive onto that. That how serverless works on various cloud premises like Azure, AWS, GCP, all these things, and how it can really be helpful in our application and how it cannot be so much helpful in our application. So let's go through that. So basically, like I think you already know that I've been previously part of Technogize. I recently left Technogize and started working for Global Logic. But since this Technogize is basically an extended version of the Technogize, so that's how I am still giving the webinar. Apart from that, both Technogize and I are available on Twitter, and we do a lot of things. So you can always follow us on Twitter to get more other things on the webinar and stuff like that. Now, about the webinar, serverless architecture. So basically, serverless architecture stands on FaaS, function as a service. So when you write web API or maybe some Node.js based, RESTful APIs, then also you write a service. But in that case, basically you are providing entire end-to-end application. For example, like when you create an single part, rather it covers a lot of
Abhishek, your
logic.
voice
For
is
example,
breaking.
like
Your
an
voice is
employee,
breaking.
it's an employee
Av-
probably.
Avishek,
Uh-huh.
your voice is breaking.
Oh,
We could not hear
yeah,
you.
I actually have
With
told
the
you,
last.
my network is running very. Actually, I'm
Acha,
on
acha.
mobile network, so
Uh-huh.
that is one of the reason. Actually, probably you are having some lag. My
Yeah.
Wi-Fi is uh, for the power
Acha,
cut.
acha.
Please
Acha.
bear with me.
Yeah. Okay. So could you
Yeah,
repeat the last sentence again?
yeah.
What you
So
were explaining?
yeah, so basically, the serverless ecosystem stands on FaaS architecture, function as a service architecture. So, what is a function as a service? If I talk about, so function as a service is basically you'll have a unit of function which basically do a certain task. So, for example, you are trying to process some data, and you write a function. Basically, even in a REST API ecosystem, you'll write a simple function, and that particular function will processing your data. Now, previously, when you don't have this kind of architecture, we used to do what? We used to write some kind of a service, rather a Windows service, and we'll skip it on a scheduler, and we put it on a EC2 container, maybe in a virtual machine, and we spin it up, and then we do the performance. So in that case, the overhead was on us, maintaining the server, making sure the server is running every time. Now imagine when you have bulk of data, then you have to do the horizontal scaling of that particular server. So for example, like you are probably dealing with some GB of data, and then your data size got increased with the course of time, and then you have to do the horizontal scaling to probably add a few more servers. So all these things, the DevOps works and everything becomes your own responsibility to ensure that your service is up and running every time. Now, with the introduction of serverless or like function as a service architecture and more towards cloud, you don't really need to bother about all these things. So basically, you can focus only on your business logic more, and you deploy the piece of code onto the cloud premises as a serverless. Now, serverless comes as a various names for various platforms. So, like for Azure, we call it functions. We on for AWS, we call it Lambda. But end of the day, they are basically running on the particular serverless ecosystem altogether for the particular cloud provider. Right now, uh, when you deploy that function, then the particular cloud provider checks that particular function whether it's compilable or not. It does have any error while it executing or not. And if it's all fine, then it will be treating as a service. And so that particular function, whenever that particular event will come, so of course your function will be executed for a particular event. So, like if you call it as an HTTP event, it will be called as an HTTP event. If you call it as a cron jobs, for example, every minute it will be running, and it will be calling some other external data, or maybe some Dynamo or Mongo based data. Then the service provider will be invoking that particular service in every minute. So what exactly you are doing? You are basically focusing on your business logic, and you are no longer looking after that whether your scheduler is running properly or not, whether your like your function is crashing for a lot of data or not. So is no longer your responsibility. So the infrastructure part is totally outsourced to the particular provider. So that is in a FaaS in a nutshell. So of course FaaS has many other benefits, but basically you are more focusing on your business logic altogether. So does this have any questions so far? Okay,
No.
so I'll take it as a no. Now, let's see the architecture. How fast is basically. Now, see. This kind of an architecture, right? Like we have an API endpoint, so kind of an API gateway. We have some S3 storage or block storage, and we have some databases, and we have some authentication services. So typically, it's like a central ecosystem. Like you have some endpoints
Abhishek?
and hello, yeah.
Abhishek, can you maximize your screen? As in, can you put your presentation in the presentation mode?
Yeah,
and to the participants as well, you can also go to your respective, what do you call, Google Meet screens and put that screen into maximum, full size, so that you will be able to see it very clearly on your laptops.
Viewed, right?
I think the screen just froze. Now it's okay. Now it's okay.
Okay. So you can see, so for individual, see if you look at this architecture actually. So for individual operations, for example, some certain wallet service or maybe some search service or individual services, we can have some functions which basically provide the particular operations. Now, in today's era, microservices is one of the most as a promising architecture because of large-scale distributions, and we are moving towards bigger applications where quick change is one of the most important thing when we develop a software. So for example, like if you're developing some software and tomorrow the client comes to you and asks for certain change, and in a typical monolithic ecosystem or single applications, you have to go through the entire deployment process for the entire application. Probably the change was for a particular service. So to avoid those cases, actually, you tend to be more on microservice ecosystem. So you have multiple services for individual responsibility, and those services will be bounded to a particular context. So for like wallet, you have a service. For search, you have a service. For any other operations, like authentication, you have a separate service. And those services are interacted to each other either by HTTP or by some event bus. So based on your latency, how you're handling that, how you're providing your distribution taxes. So based on that, you're doing that's a different scope altogether. But end of the day, you have multiple services to cater your individual operations. Now, there will be cases, say you are a startup and you have limited money and you cannot really afford to have multiple EC2 containers or virtual machines, and when you're not sure that how many customers you will have on your applications when you're launching that. So cost is one of the bigger role in your to run your business. Now, so what will be your approach basically? Your approach will be you want to pay to the provider when you basically use their service. Now, in traditional system, you don't have such options. You have to buy the server or you have to rent the server and you have to deploy your applications over there. If you're trying to do in a microservice ecosystem, you'll have to run multiple VMs or multiple EC2 containers to ensure that your multiple services are deployed, and the other like the event bus or like Kinesis for distribution of messages from two services or multiple services. So all these things you have to ensure that these things are running. Now, and as a startup, you don't want to go to all these things. So basically, you want to ensure that okay, whenever my customer visits my applications and they are using my applications, for that particular charge, I'll be paying to them to my provider. So to achieve that, actually, you need a certain ecosystems. So back in 2008, if I'm not wrong, actually, so that time this particular serverless ecosystem started using by Google and companies like Amazon. So maybe that date may be wrong, but yeah. So from 2014 onwards, AWS Lambda very much got popular, and eventually, in today's era, serverless becomes one of the most also promising architecture and promising services for the cloud providers. So what happens actually? So if I look at this architecture, so you have an API call. So API call is nothing but an API gateway. It's kind of a reverse proxy. Think of the reverse proxy that you have certain endpoints that's like the endpoint is basically routed to the particular Azure Lambda whenever it comes. So for example, you are looking for the flight reservation system. So imagine like Make My Trip. It provides list of airlines. So you go to their applications, select the particular destination that you are traveling, so to and from, and the date, and you click on the search. Then basically the API gateway will receive a particular request to their interface saying that, hey, I'm looking for the resource of this particular URI. So sitting behind, there will Azure function or maybe a Lambda based on your cloud provider will get that request. So before that request comes to the Azure function, that function was in sleep mode. And that function is not actually considered by the provider that it's running. So it's more like whenever the request comes into the Azure function and it starts its operations and it ends its operations. So during that time, the server will be up and running for the particular function, and whenever it completes this function, it will be die down. And you are paying for that particular piece of cost. Am I making sense?
Yes, Abhishek.
Okay. So now you are reducing a huge cost altogether here because you are no longer having a server which runs 24/7 and charges you for the whole duration of time, even though the application probably used some 4 hours throughout the day, and still you are paying for 24 hours. So that is one of the saving. And another thing is that tomorrow you get a huge spike. So for example, there is a like coronavirus happened, and before that, if we get a intimacy that okay, the lockdown might happen, so a lot of people who are who actually is working in a different state and their hometown in a different state, then we could have seen a spike saying that okay, they all want to go to home. So in that situation, actually you can have a huge spike onto your application. Now to do that, actually you probably do a horizontal scaling. Now to handle those situations, if you're a startup, you don't really have those kind of resources and money altogether to handle or cater such things. But in Lambda or in Azure Functions, you have that facility that it's auto-scalable by the provider itself. So whenever you have a spike altogether, it will be scaled up. So multiple instances of the particular function will be added and it will be catered. But it not necessarily all the function will be scaled. It will be scaled on that particular functions which actually getting the spike. So probably in your application, you'll have 15 functions, but 3 or 4 will be the actual major functions which handles your MVP or like minimal viable product. I mean that particular functionality which basically helps you to earn money, right? So because if you see any product, so there's like for the Swiggy or like I'll say what Make My Trip, they have a lot of functions in their applications, but actually they are a reservation system. So like either they have hotel services, so that is one, and for the air booking services, that is two. So this kind of 3 or 4 functions are the major in their entire applications, which basically gets a huge hit altogether. So your scalability also happened to that level. So that is one of the bigger advantage, I'll say. So if you want to move into, now think about perspective as a microservices. So in microservices, you're trying to do the same thing. You're trying to achieve what? For individual context, you'll have separate services and which are isolated from each other, and they'll be talking to each other through either by HTTP or by event bus. But yeah, I mean, again, for functions, actually, you're doing the same thing, but you are no longer taking care of your servers. All right. Okay, so the advantages. Of course, like I've said already, the automatic scaling is one of the biggest advantages. So you don't have to bother about that. Deployment part is quite simple. You don't have to write all those, DevOps stuffs all together. You simply can have a CI/CD pipeline, and you can simply achieve that to deploying it to the particular bucket. Deployment stuff varies a little bit based on the particular provider that you are choosing. So for functions, I mean Azure Functions, they have a different approach, and for Lambda, they have a different approach. I've never used GCP, so I'm not really sure, but of course, they will be similar to the thing. So it's not a entire change or, showstopper altogether for the deployment part. It's quite simple than a regular deployment process of your, I'll say, RESTful APIs or REST-based service and a complete SaaS-based approaches actually. Cost optimization, like I said, you are paying only for what you're using. You are no longer paying for the entire process. And cloud native, yeah. So cloud native is like cloud native applications are called 12-factor applications. So if you read more about the 12-factor applications, it's a separate session altogether. It cannot be covered in the session. So serverless are more tend to be 12-factor applications prominent. So for example, almost like all the serverless applications are follow or can be easily followed with the 12 factors rule. So you can become more cloud native altogether. Now,
yeah. Avishek, what are those 12-factor rules?
So there are 12 rules. So short. So 12-factor rules are basically how your CI/CD pipeline should be there, and if you are moving to cloud, actually, then what are the resources that you'll be using, and your entire ecosystem should be on cloud, that you are not actually using any third-party resources to run your applications. So probably there are some deviations, but of course, you are not altogether a part of your applications on cloud and part of that in a separate network altogether. It's not really like that. So I can share that into the video actually. I mean, end of this webinar, because that's like explainable that how you are doing and what are the process that has to be followed. So I can share that all together. You can PM me on LinkedIn. I could share that to you. Okay, because we have a time limit in here, so we have to cover that all together. How Lambda works on AWS. So look at this diagram. What do we have? So basically, we have some web authors. So basically, there's some actors, you can say. And these actors basically going to some containment system. It's an on-premises stuff probably. and then it goes to a AWS ecosystem, which is a VPC, of course, because you don't want to publish your data to outsiders. So you want to ensure that all your stuffs are basically inside a VPC network. Now, your first request, wherever a request goes to CMS wants some and EC2 container goes there, and again there are some redirects EC2 container and CMS to container, and that goes all together, and that may not go all together, or maybe you cannot have that EC2 container cluster all together. So you can straight away your request goes to S3 bucket, and S3 bucket probably goes to your CloudFront. Again, S3 bucket can be invoked based on a Lambda. So Lambdas can be invoked in multiple ways. So it basically invokes on a particular event, and that event can be anything. So event can be like HTTP event. Event can be like your some document pushed into an AWS S3 bucket. So you can raise a Lambda event. Some cron job scheduler. So whenever you basically run a function based on 1 minute every time, and you basically want to do some operations post to that. So in this session, actually, I'll be showing you that we have a bot, some kind of a Twitter bot, basically, which runs on every minute, and it finds all the tweets that have certain hashtags, and then it will be retweeting it. So what it happens actually, so it running from one of the AWS containers, I mean Lambda containers, and then it checks for all the Twitter or all the tweets having a hashtag called serverless, and then whenever it finds that particular serverless, it retweets that. Now, the retweeting code and everything is a separate thing altogether. So you can implement based on your requirement. So what is the main focus will be that how it runs on the cron operations. So I'll be coming up with that thing also. And in Azure Function, so if anybody is coming from the Azure background, you can even see that the same thing. So like you have a device, so like think of an IoT device, and IoT device sends a message to the event hub. So event hub is similar to the Kinesis for the guys who are coming from AWS background. So in Azure we call it event hub, and in AWS we call it Kinesis. So event hubs have some triggers. So these are all distributed messaging system. So you have some trigger, and based on the trigger, actually the function app or the Azure function, that's again a serverless application, gets invoked, and then it basically do some operations. So probably it can be pushing some to the storage queue, or maybe writing some operations to the Cosmos DB. And Cosmos DB is a separate application altogether. It's basically a DB, can have NoSQL, SQL operations altogether on that. Again, you can have HTTP request, and HTTP request goes to the API management, which is the API gateway, basically, like we call it in AWS. And that API gateway again triggers a function app, and the function app doing some operations altogether. So this is how the serverless applications works. So it's not necessarily has to be in the forefront of the applications, but rather it's sitting one layer behind of the face of the applications. So a typical serverless applications cannot be as a entry point to the application. So entry point has to be some event. So event can be anything. API management or API gateway can be an event, or event hubs can be an event, or maybe your CloudFront can be an event, which basically can raise an authentication event or a HSTS event, and that can again invoke a Lambda function. All right. Any questions so far?
Yeah, I have one question.
Yep.
Can we have this architecture without function app? Means anything, means in Azure we have a Lambda function, and here we have function app. Without that, is it possible to we don't have this function app? We can directly call the Cosmos DB or storage queue services.
Yes. So basically, now if I talk about this diagram, like its event hubs is basically what? So event hubs is basically a distributed messaging system. So like you have Kafka. So if you have worked with Kafka already, then you basically know how this distributed messaging system works, or maybe Kinesis. So think of a queue basically. So think of as a queue. So queue, now you have multiple queues altogether. and they've been distributed based on the load. So this is what the event hubs altogether is. Now it cannot really call Cosmos DB directly. Cosmos DB is a database, right? End of the day.
Yeah. Yeah.
So you need some in between app. That can be
Okay.
function app, or that can be a virtual machine running with some API code altogether. So
Okay.
the main objective of serverless is basically what? That you want to optimize your cost. Now, if
Okay.
you replace this function app with a virtual machine running 24/7,
Hmm.
and probably your device, IoT device, is pushing message once in a day or twice in a day. Okay, it's not so popular. Probably it's still in evaluation period, or maybe your device is not so communicative. Rather, it takes care in the local already, and probably it's pushing some of the data that has been gathered throughout the day to the server for some research purposes, right?
Mhm. Okay.
So in those cases, actually, you don't really have to spin up your containers throughout the day. I mean, that won't be a cost effective thing altogether. So you basically need to do what? You basically get some data from any of the data source, and then you store that data or maybe process that data, right? So in those cases, actually, there is no point of spinning up a container and running it for throughout the day. Of course,
Okay.
the containers are needed, like whenever large scale data altogether, and probably some machine learning data that you're trying to train some models, and you probably need to spin up your containers or run your containers for 8 hours a day just to train some models. Of course, you cannot use functions app or like lambdas altogether, because lambda and functions have some time boundation. So I'll get to that again. But yeah, I mean, for smaller operations, for small scale operations, you can always think of lambdas. I mean, think of a unit of work. I mean, you have a single unit, and that you want to do the operations rather, and you know that the operations won't take a lot of time altogether. It's like a small data operation, small data centric operations, or maybe some uh, kind of relaying a message. So like you get some message from the event hub, and you filter out some part of the message, and you push again to another event hub or another service bus, right? So in those cases, actually, you can think of functions app or lambda. Does that answer your question?
Yeah. Yeah. Yeah.
Okay.
Thank you.
Yep. Benefits I've already covered. Now, there's a thing actually. So, like I said, serverless functions are almost like in sleep mode unless you have a request. And imagine that your application is not getting used by the users for last couple of months, maybe, or maybe days. Okay. And again, suddenly one user downloads your application on the Play Store and start using it. So then the cold start thing comes altogether, because your functions are not being used, and suddenly somebody knocks it. Hey, I want this data. Now the function has to be run at the first, and then it will be start getting invocable, and then the lambda operations can be performed using that functions, and then it can be returned. So that is the cold start. So whenever your application is not actually being used for a longer duration, then you can face a cold start problem with a serverless application. So that is one of the drawback, you can say. So that can be solved in various ways, but if you don't want to use those operations, I mean, kind of a tweaks to ensure that you don't have a cold start problem, then you may face some issues, but that is like a minimal thing, because the cold start operations won't take lifelong altogether. And but yeah, I mean, still it has a user impact. So for the first user, may take some additional time, probably 2-3 seconds or more than that sometimes, to be ready to cater the user. But yeah, I mean, that risk can be takenable if you're kind of want to save your money and don't want to go to a VM or container based approach for your functions. I mean, that is the one of the thing. Or otherwise, you can actually have a ping operations which runs basically every day or sometimes like once in an hour, which kind of a cron job basically that can begin a server which pings those particular entry point of the applications to ensure that you don't have a cold start problem whenever your user come. So that can be another approach to sort out your issue.
So Abhishek, I have a doubt. So if
Mm-hmm.
we are pinging something continuously, so aren't we losing the advantage which we get from the serverless, that it shouldn't, that time saving thing, that since I think the server only stops when when there are not enough requests,
Yep.
or that there is no request for some duration of time. So if we are
Mm-hmm.
continuously pinging the function, so wouldn't it lead to continuously running it against same as traditional architectures?
Yeah, pinging is not a, of course, it's a very good approach altogether, of course, because like this is one of the thing actually that you have to go with or live with it for now, the cold start issue of the serverless. So if you can, of course, live with it, then it's perfectly okay because the cold start problem isn't a game changer altogether. And again, if you talk about VMs, of course, VMs is a better approach if you don't want to fall into the situation of cold start, then of course you can go for VM. I mean, if you don't really have VM options and you cannot really afford to have a cold start option, so in that case, actually you can think of the ping. But of course, ping is not a very good approach. It's more of a hack to ensure that you don't really fall into such situations. This is
Okay.
yep.
So, do
Yeah.
we, is it the case like there is a constant, is the is it the way that can we reduce the cold start time? Are there any guidelines so that we have very few amount of time that that cold start is taking?
So cold start is not necessarily there is no such guidelines actually for cold start. At least I'm not really aware about the cold start guidelines. But what really happens actually for all the cloud providers, like so serverless not necessarily means it doesn't really have a server. Basically, you are using the provider server or you are renting it for the particular duration of executions. Now, if you don't really using it for a longer durations, for example, like for last 7 8 days or for like 10 days, you have not pinged your function or like nobody actually invoked your lambda or function, then basically those functions become goes to in a kind of not used state. Now whenever a new request comes, actually then it has to be moved to the particular instance of the provider server, and then it has to be invoked. Since, see, for VM, what really happens is it's running throughout the day, throughout the duration, your VM is up and running. So unless you take down your VM is basically up and running. So you don't really have this cold start problem for that. But for serverless, actually, you don't really have a VM or you don't really have a container. You rather borrowing or renting your provider's instance or containers or server altogether, right? So this is what it is. Now you cannot really avoid a cold start problem, and you cannot really go to a provider say that, hey, I want to run my functions throughout the day when it's not coming, but it has to be serverless. It cannot be done, right? Because serverless ecosystem is like that only. So yeah, I mean, if your functions is not getting hit and it's not in active state altogether, then it will be go to a secondary state of execution. That means like your function will be loaded onto the server only when it gets a next invoke. So yeah, I mean, you cannot really.
Yeah, actually, the thing like does the size of that function, the size of the code the function is going to execute, does
Mhm.
it matter? Does it adds up the time required for the cold start? That means
No,
the lesser the size of code, then there will be lesser the time required to cold start.
no,
And if the size of code is more and getting increased, the cold start will get increased.
no, it's not
Is
really
it
like
the
that.
case?
So serverless basically have a duration of execution limit. So by default, lambdas have 3 seconds of execution, and Azure functions have 2 seconds of executions. But that can be extended to a certain duration of time. Of course, serverless functions has to be limit to a particular execution. So your serverless functions cannot run for longer duration. But that is not related to cold start issue altogether. Cold start means like whenever your functions are not getting used. So imagine that you have a function which used to do some work, but that particular feature is no longer used by the user. Probably it's not getting used so much, right? Now that means what? That your function, no matter how long it used to take to perform an operation, but that function is no longer being used, at least for last 7 days. Nobody has touched that function. Now cloud provider won't be keeping that in their active memory of execution. So they'll be shifted out. So they have a different algorithm to handle those things. And in that case, actually, whenever your next request comes in after 7 days, they have to first bring it to the server for the execution level, and then it will be executed. So that part actually takes some time, and that is why the cold start problem happens.
Yes, thanks.
Does that answer your question?
Yeah, thank you.
Yeah. Okay. Now the thing. So how we can write serverless? Now, of course, there are lot of packages available. Like if you're using Azure Functions, so with the Visual Studio 2019, we provide Azure Function app in the application. So that is one of the good thing. But imagine that you are into a hybrid cloud probably, and you have using AWS Lambda and Azure Function simultaneously. Okay, so part of your applications into Azure Function, part of your applications to AWS. This happens often. So for a bigger enterprise applications, we do use sometimes this kind of things. Now, you cannot really write a Lambda function using Visual Studio. So there is no such templates, stuff like that. So if you want to opt for a generic template or generic kind of an approach, and of course, if you want to write your Azure functions, not using C#, but maybe using Node.js or any other non-Microsoft languages. So serverless supports a lot of language altogether. So Lambda supports most of them. So like you can write your function Lambda apps using Node.js, using TypeScript. I mean, TypeScript is basically a Node.js type version. Using Java, using PHP, using C#, using F#, using Go, Golang. So Python, of course. So all these things are available in in Lambda and function. But when you talk about templates for Azure functions, you'll have only C# provided templates and F# provided templates and Node.js provided templates in your Visual Studio application. Pythons are still kind of a post beta, but it's not supporting hugely altogether. But imagine if you're trying to write some Azure functions using Go, then you have to look around for that. So this is one of the challenging part becomes, because in cloud ecosystem you can have developers from various backgrounds, various language backgrounds, and you want to you cannot really change the comfort of language altogether. And again, there are some operations which can be handled easily by Go or PHP that cannot be handled very great way in Node.js maybe, or vice versa. So you need some kind of a common framework which can help you to build serverless applications for almost 3 or 4 major provided cloud platforms and almost supported by almost all the languages. So serverless framework is one of that which really helps out to do those things. So it's basically a node-based package, NPM package, and that can run. And also one more thing actually. So when you're building your serverless applications, the most the thing becomes the testability of the functions in the local. Now you cannot really go to the AWS editor and try to write the function and run it from there. That will be a bit tough. And again, if you are trying to do it in Visual Studio, then Azure Functions app need your active Azure credentials to do a temporal deployment into that and to test your functions. What if you don't really want to go for that? What if like you want to make sure that your serverless functions running locally completely, then you can actually deploy your function. So to do those things, actually, you don't really have any structured framework. But of course, there are a lot of frameworks, but they don't really cover all of the features altogether. So serverless framework does provide that. So when I say serverless framework, it's the framework's name. Let me open their website. Let me stop sharing because I'm sharing one of the window, and then I'll be sharing the entire screen so you can see that. Okay, so I think you can see my screen, right? I think you are.
Yes, yes.
Yes.
So this is serverless framework. So when you're trying to develop some applications using serverless framework, I mean for serverless for any of the cloud provider, then you can think of this framework actually. So this is an open source framework. Of course, it has some premium features which comes with a price, but technically to develop function, you don't really go for those premium features because those are more of like for logging and tracing your your functions applications and how they're performing. So those things, if you're not really tend to use the cloud-based solutions altogether that has been provided by the AWS or Azure out of the box, you can opt for those pricing models. But those are like a separate thing altogether. You can of course explore them more. But as a product, in a nutshell, it basically provides uh, any kind of serverless applications built using Node.js, using PHP, using C Sharp, using F Sharp, using Java, using Kotlin. So based on all these languages, and it primarily support three of the major cloud platforms. I've tested them basically: GCP, AWS, and Azure. It's it's basically a Node.js based framework. So you basically have to have Node installed in your local box, and then you can install it using npm Node Package Manager. And once you install that, basically, then you can use the CLI feature of the serverless. Since we'll be doing that using Node.js today in the session, so I'll be showing that. So if you have laptop or computer handy with you, then basically you can go through that. Try doing the same in your box. So that will be more like a handy session. Huh. So, I have shared this single tab again. Let me share my Visual Studio Code. Okay. Okay. So, yep. My code size is particularly small, so let me increase that. Okay. So can you see my code all properly?
Yes. You can maximize the screen as well. I don't know if it's possible.
Okay. I don't know how to zoom the PowerShell altogether. So once you install it, basically, so you can install like this: npm install. I already have installed serverless, so I don't really have to do it again. But yeah, I mean, you can run this command in your local box, and you can install serverless in your box.
So Abhishek, I have one question. Like serverless is the like it's a framework or it's a cloud provider? It's not a cloud provider, right? So what it
No,
achieves?
serverless is a framework. So when you develop the application using or trying to develop an application on serverless or like for a serverless way, like for Lambda or kind of a function, then you need some kind of a framework to manage the entire DevOps process, to manage the entire code or source code, how to write that, and how to ensure that it's working perfectly fine. Because you need to do those operations. So like you need the testability of the function. You have to ensure that the functions are running, because you cannot really deploy that in your serverless box and then start testing it. That's like not a good approach when you're doing it at an enterprise level. Right. So probably you have multiple team members in sitting with you, and they cannot really go to a sandbox account of the AWS or Azure and trying to write the function and test it. So you need something on your local box so that you can actually uh, do the operation in a robust way and in a scalable manner. So like you're writing the particular piece of functions, and then you're trying to test it in your local box. And once the testing and the implementation is done successfully, then you can deploy it. And deploy shouldn't be like going to the sandbox account directly and doing that, rather should be through a CI/CD pipeline. So to do those things, actually, you can of course do that without using serverless, but that will be like a huge process altogether. But serverless provides you a lot of features out of the box. So like the deploy, SLS deploy will simply take your profile credentials. Like for Azure or for AWS, you can have the particular CLI installed in your local box, and you can map the particular sandbox account. And whenever you run the SLS deploy, to be deployed to your cloud provider. So this is one of the thing, or like when you want to test it, like serverless offline. So serverless offline basically creates the sandbox in your local computer, and you can actually test all the particular features that you want to test. So you don't have to have a cloud provider account till that level. So only when you need, when you're trying to deploy it. So that is one of the bigger advantage actually. And of course the region that you're trying to test. So basically you can mock the regions, and whenever you're trying to based test cases or like C# based test cases, of course you can use them. So these are the advantages of serverless frameworks. So is there, I'm sorry, questions? Arpit, I think your name is Arpit, right?
Yeah. Now it is clear actually.
Yeah. So it's taking some time, maybe open another instance. Actually, it's like, I don't know what happened to my area. It's like having a power cut since night. Okay, so let me close the other window. So once you install it, basically, once your installation is done, like I shown in the last screen, if you write serverless version, then you should get the particular. Now, how you can create an application using serverless? So you can write something like this. Why I'm giving help? So help basically help you understand what particular templates, like I've shown you that, told you basically that you can use Node.js or other languages in your ecosystem, but how you can create them, how you can use them. So if you write serverless create help, then it basically tell you that what are the templates available by default. So if I if you can see my screen, can you see my screen?
Yes, Abhishek.
I mean, it's yes, clear, right? So you can see that if you are using double hyphen template, it will Gradle or like a Node.js TypeScript or Alexa based TypeScript. This is for AWS only. And then again, you have for Google based Node.js or Python or Go, or like for Azure C#, Node.js, TypeScript, Azure Python. And this is how basically that you are actually using a single framework, and you're writing serverless computing based functions for almost like all the cloud or four major cloud providers, right? So if I follow this template, and if I write serverless create template, say like I'm using AWS, this one, let me copy that. All right. I should create new template project. Okay, I did a mistake actually. I shouldn't be doing that in here. Let me change that directory. Let me create a directory called samples. Okay. Now let me run the command again. It should create a template project for me. Now, if I write code dot, so you can see that it creates a couple of functions, a couple of files. So one, it's creating a serverlet.ts file, a tsconfig file. So serverlet.ts file basically tells you that what are the particular files it has been there, and the package JSON, which basically is the node-based package. The handler.ts is basically the entry point of the application. So the entry point is basically what the API gateway proxy handler. This is a class that comes with a serverless out of the box for AWS Lambda package, and it has the event and the context. Event is basically whenever, like I said at the very beginning, that all the serverless functions runs with an event. Now, with the event, actually you can pass some data. So event body message basically contains the data that you are passing to the particular function. So using that parameter event, basically you can access the data that you want to use it, or like that you want to process. And then of course you can return the particular functions with this, with this as a response altogether. All right, this is how it is. So I have a sample project basically that I've created. So of course you can. So now this is the YML file, serverless.yml file. So with the template, actually, it's no longer providing the serverless YML file, but you have to create one serverless YML file by yourself, which basically provides you the particular deployment script and how the function should be invoked. Now, this YML file basically what? As a service. And then you have to provide the particular function name or the function application name. So basically, functions are basically treated as an application in the particular cloud provider. So you have the app name. So whatever name you provide, that will be treated as an app name. Of course, if you're using Node.js or TypeScript-based application, then you have the webpack.config. It's typically related to the Node.js and JS-based languages. So if you're using some other language, you don't really have to go through that. I'll come to the plugins part next, later. So next on the provider. So provider is basically which provider that you're using. So if you're using AWS, it will be name as AWS. Otherwise, it will be Azure or GCP, that way. Next, as runtime. So which particular runtime you're using? So for Node.js, we have Node.js 12.x, which is a 12 or onward versions. So if you're using .NET, then you can use .NET Core 2.2 or 2.1 and onwards. So that way, basically, I'm not really sure the Java and the Kotlin runtime. So probably they can use Java 8, Java 6, some like the Java-based versions. So this is how you have to mention the runtime. The API gateway, basically. So API gateway, like if you are using API gateway, then what will the compression size? So you can mention the particular gzip compression size for your endpoints. Next comes the environments. So environment basically the particular environment for AWS Node.js that you want to use for .NET Core. That's a different environment. Next comes the functions. So this is the one of the most heart of the particular YML file. So that's the first thing is basically what will be your function name. So when I say function name, that means like if I go to my code base. By the way, I'm telling a lot. If you guys have any questions, just knock me right over there. Okay, I know I'm telling a lot. I'm going through a lot of code. So if you have any doubts, just let me know. Okay. All right. So 100 days of code. So if I go to here, you can see there's a file called 100 days of code. So you basically, as a standard, this file name and this name should be same. So this is one of the standards that we follow. Next comes as a handler. So handler basically the entry point of your particular file. So like I've shown in the particular last code that we have created as a template in here, you see that there's a constant hello. So that is basically an endpoint of the particular application. I mean entry point of the particular application. So here I'm saying my YML file that for 100 days of code, the entry point should be folder name NinjaBot. Then we have 100 days of code as a file. Then inside that we have a function called retweet. So if I go to that file, we have this retweet function. It's basically an asynchronous. It's again a Node.js code. So that's pretty straightforward. Basically, we are calling some other internal functions, generate Twitter handler, and then we are getting some responses out of that. And we basically doing some operations. So I'll not go through those codes actually, because I know we are here from various language background. So, but those who are using Node.js can easily understand that what we are doing over here. Next comes as events. So when I say event, basically, so how this function should be working. So these functions can work based on schedule. So schedule means what? That on every, so it should run on a particular time interval. Schedule basically tells the serverless framework that, hey, this function should be getting invoked on a particular time interval. So I'm saying that rate, which is a serverless function, in every 1 minute, it will be invoked. All right. Next, other files are of course not really in the scope, like the Tsconfig.json. So the guy who will be writing the function using Java, you don't even have those functions, so I'll not be covering them. But of course, these are like part of your TypeScript and Node.js based application configurations. So if you're using that, make sure you have those files ready in place. But I'll be covering mostly the serverless YML file because that is the one which will be common for almost all the serverless ecosystem projects. Now, if I go to the terminal, I can write like this. You may have a question actually, what is a serverless offline? But I'll come to that later. So you can see that it started getting executed. Now, if I wait for 1 minute, it will be, see, it's tweeting a lot of posts. Okay. So an error occurred to it. Twitter has already retweeted this tweet and blah, blah, blah. So basically, if we go to the Twitter account of this particular user, which is a dummy user, and if I refresh it, I may not refresh it even. See, basically, I have just retweeted all these tweets. Okay. So 6 minutes ago, this guy has been posted and I retweeted a few minutes back, and so on. So if you just keep it running for a couple of more minutes, you can see that it's been retweeted again. So this is how the bot basically works. So that's a different thing. But yeah, I mean, if I just hold it for another minute, you can see the tweets has been changed. Now next comes the plugins. So what is a plugin? Now serverless webpack is basically the build plugin, and .env plugin again, the particular accessing the
Hi,
environment
Avish.
files. Yeah.
Yeah, hi. I have a question. You mentioned about the schedule perspective in the YML file.
Yeah.
But what
Yes.
if I am not sure when my function is going to be executed? Like these things could be these functions could be called maybe very rarely or seldomly called. So I don't have a definite schedule. So how will we configure that?
Yeah. Yeah. So I'll come to that later as well. So like.
Okay.
You can have various ways, like you want to expose your functions through an HTTP API gateway, or maybe you want to run it as a scheduled way. So I'm showing the scheduled way as of now, then I'll be going to how to host it as an API through API gateway. But you need some event, right? End of the day, you need some event.
Yeah. Yeah.
So yeah.
Okay. Thank you.
Yep. All right. So yeah. So serverless offline basically is a package that's basically helps you to test your serverless function in locally. So it creates a similar kind of ecosystem like the cloud provider does in their network. So technically, you don't have to deploy your functions in the cloud box to test whether they're working or not. Rather, you can use this serverless offline framework in your serverless project as a plugin, and you can run the command serverless offline, and you can use it. So how you can install serverless offline in your project? So basically, to install that, so you have to go to your project directory and hide it. Okay, let me stop that. So it's been retweeted a lot. So if I go back to here, I should see new tweet. So you can see that it's been retweeted again. So previous tweet has been changed, and we have got this many retweets. So previously it was retweeted up to this one, and now a few minutes back it's been retweeted all these new tweets. So that means the function is working. Okay, so you can use something like this: npm I dev serverless offline. So that should install it. I mean, I have already installed serverless offline. That's why it's working for my project. But yeah, I mean, you can of course install that, and rather you should install it to write your first serverless function. All right, and once you install that, so it's not necessarily going to add this particular serverless offline plugin into the plugin section. So you have to write the plugin sections. I mean, you have to add the particular serverless offline plugin in your plugin sections manually. Okay. So any questions so far?
No.
Okay. I'll take it as a
Sarthak, you have a question?
No, thanks.
okay. Cool.
So I have one question,
now,
Abhishek. So Abhishek,
yeah.
so this
Yeah.
plugin you have installed in Node.js, right? But if we are working on Java side, so what we need to do in Eclipse or some IDE, we need to install this plugin. So how can we install?
So I have tested serverless offline on C# and with Node.js. So of course it's working over there. For Java, I think serverless offline doesn't really support much of that. So probably you have to go through the serverless GitHub repo page, and you can see that whether they're supporting for serverless, I mean offline version of the Java projects or not. Because I'm not really a Java guy, so I don't really have much clue on that. That whether it's really supporting Java projects so efficiently like it does for C# and Node.js projects. So I am not really sure, but of course there should be a way around. I think serverless offline supports that. So you can go to their GitHub page. So if you search for serverless offline, I can share the GitHub link over here. You can. So this is the npm package. So npm package, and from there you can go to GitHub. So here's the GitHub link over here. So you should go to the npm and their GitHub repository homepage and see over there what they're supporting and what they are not. But yeah, it does support for Python. It does support for C#. It does support for Node.js. So it supports almost major promising languages. So of course for Java, they do support it. Yeah, you test that. Fine. Any other question? Okay, so I'll take it as a no. Okay, so like there's a scheduler part is done. Now, what if I want to go through? I mean, do something more different. Say like I want to, instead of writing on an event, I'd rather go for something called API type. So This is another project that I've created actually. So all these projects are available on GitHub. So I can share the links. You can probably take a look of that whenever you want to do. Now I'm not going to explain the upper parts, which I've already explained. This custom part I'll be explaining in a short, and the provider I've already explained, and environment I'll be explaining that. Let's do the functions first. Now you can see that we have a create in here. So if I go to the project structure and if I open to-dos, and if I can see there's a create.js function. So create.js basically what is basically a Node.js function. So if I go to serverless, I'm saying to-dos, then create.create. That means my file name is create and my entry point is also create. Now it's not really a typical schedule-based function. Rather, it's more of like a event or like more of like a RESTful API. So it should provide you a full-scale API endpoint, and you can basically use those endpoints to store your data or to retrieve your data. So how we can write that event? So events is basically serverless defined parameter. Now it's mentioned that event is basically HTTP type. So you have to pass HTTP type. Next is a path. So what is the path that you're providing? You're providing to-dos in here. And you can of course use a versioning of API/v1, what you want to do. And the method. So method is basically for create, we're using post. Of course, you're using any other HTTP method based on your necessity. And if it's, whichever is applicable. Then again, we have another function called list. So like you can see, you have a list file, then the handler. Now that's all for get. Of course, cross-origin request. So that's of course has been true. So because I'm expecting the calls that is from a different origin altogether. So of course I have to make it true. And then the get. Now this function won't be running because in local, because I have not set up the local Dynamo, but I can of course deploy them in server. So let me use serverless offline. See what isn't provided to me. It's provided the post URL. So there is a def to-dos, the get URL. I have another URL called to-dos with ID. So if I go in here, you can see there's a path which basically expects some ID. So this is the get for that. Next, I have the update URL, which is basically the put. So if I go to here, you can see the update. It's basically taking an ID and updating. There's a put verb over here. Then I have a delete URL. And based on that, we have a delete, and method is delete, and the course is true. All right. So serverless simply spins up the serverless offline plugin basically spins up a particular local host, I'll say web server for you, and then that particular web server, and even it's provide the particular region of the AWS that is a preferred region. Of course, you can change the region using the serverless YML file, and then it creates a particular endpoint that you're looking for, and it's basically, and you can basically use them. So you can use the Postman or any other, I'll say, Postman kind of tool, which basically helps you test the RESTful APIs, and you can try them out. Next, so I'm going to stop it over here, and I'll be explaining you that what are the other things that it has. So the custom table name. So as a backend, actually, we are using DynamoDB in here. Of course, you can use any other DB, but I prefer to use DynamoDB because of my own reasons. Now we have a table called table name to-dos table, and stages. The stages are basically that this particular table will deploy to which particular environments, for dev, for production, for staging, or for any other environment. So that you can mention over here. Port, of course, which particular port you're trying to access or trying to communicate to this application, whether it's an in-memory application, in-memory database or not. Okay, so these things are basically part of the DynamoDB configuration. So with the custom attribute basically provide this DynamoDB configurations in the serverless YML file. Why do you provide the serverless YML file? Because you won't be creating the DynamoDB configuration manually. Rather, you'll be using Serverless Framework or Serverless Deploy command to create those tables for you. So that is one of the advantages of Serverless Framework. All right. Next is like the serverless AWS Dynamically local. So like I said that you can use serverless offline framework to ensure that your application is running locally or not. Same as like DynamoDB also provides, serverless also provides a DynamoDB local plugin. So this DynamoDB local plugin helps you to configure the local instances of the DynamoDB in your computer, and you don't really have to go to your serverless application. In the cloud provider altogether. Rather, you can simply use the local instance of the DynamoDB, and you can, use that to test your application whether it's working or not. So this is one other thing you can try it. And yeah, so the actions that I'm going to perform on this particular DynamoDB, I'm going to mention over here the query, scan. So those who are kind of used to the NoSQL databases, they can of course understand that what is a scan and query and get item, put item, all these items features. So this is the environment part, is basically the DynamoDB table and the self custom table name. Because in the environment, why do I use that? Like I said, when I'm running the particular serverless DynamoDB local, I have to mention my particular table name in the environment or .env file. So if you're using typically any kind of language, this environment becomes important, because you have to understand that. Just a moment. So you have to understand that, or you have to tell your serverless framework that which particular table has to be communicated and which particular table, where the table has to be inserted, value has to be inserted. So that is why these environment variables are here. And this particular variables has been used in the application. So if I go to my services, say like create service, so I don't know, probably, yeah. So you can see that in the process env, I'm using this is offline particularly parameter, which has been mentioned in here in my environments file, and I'm trying to access it in here. So in Node.js, we use process.env. In C# we use a different approach. But serverless YML files, environment file variables can be easily accessed through your code. And based on that, you can certain tweak your application's behavior based on the particular environment. So like whoever is coming from .NET core background, or then they can relate to that is development mode that we have in startup.cs file. So if it's in development mode, then we do some certain special configuration in the middleware. So that is one other thing actually that we can do using serverless framework. Okay. Next is like I can deploy that application. Let me deploy that application.
Hi, Avishek. I have one question. Shovan here.
Yeah, sure. Yeah.
Okay. So let's say like one of my serverless function is required to have one dependency on certain npm package. Let's say you said serverless that will receive the messages from a queue or something, or yeah. So let's say I emit one message on that RabbitMQ, and that serverless function is listening to that. And I want to use some JSON serializer or something to use. So there's a dependency, right, on that package. So how will it handle on its own from that import stuff, or we need to declare it
No, so the plugins that are related to particularly with serverless framework, we have to mention that in here. But those are related to typically your code level, you don't have to use them, because see how Node behaves actually. So whenever you basically deploy your code to the node ecosystem, the cloud provider will be running an npm I over there, npm install over there. So all of the dependence will be downloaded over there, of course. So that way
Okay.
you don't have to. So your package.json file is there, right? You have
Yeah.
package.json file, which basically mentions your all the required packages to run your applications. So like we need the AWS SDK, we need the Jest, we need the serverless offline as dev dependencies. And we have some dependencies called serverless, Dynamically local, supertest, UUID. Okay, all these things that has been there, that has been needed to run this application. So whenever you run npmi, this package.json will be read by the npm package manager, and it will downloading all the particular references to your local. Now think of like a typical, I'll say, .NET ecosystem. Now you have all your NuGet packages in place. Now you can of course using the using statement, and you can use those packages in your local box, right? It's more of like a restoration of the NuGet packages that we do in .NET, and same as like npm. It's quite same.
Okay. Okay. Yeah. The reason why I asked, because I see a lot of like functions in the same project, right? And those like functions will be like deployed separately, right? Or like, yeah, or maybe individually.
Yes,
But
of course.
let's say like this create basically depends on something like DynamoDB. But one more like function I have that really like doesn't depend on any databases, or doesn't perform any database operations. So
Of
I don't want
course.
to install that DynamoDB like package for that endpoint. So
No.
like
So what really
in,
happens? So whenever, so let me show you how. So what really happens basically, when you just create a service project,
Mhm.
how it, now think about like a microservices perspective. You can have a service project which has a certain bounded context, right? Now, bounded
Yeah.
context means what? That you have a certain context defined. Say like you have a product service. Now, product service can have multiple endpoints. So some is for taking the product, some is for deleting the product from the inventory, some are for updating the product quantity. Okay, it's more like that. So if you defining a serverless project, and probably your individual endpoints are deployed as a separate functions in the individual project, even though your particular context won't be changed, right? So when you create a particular project in terms of architectural approach, you have to define your context, and based on that you have to create your project. So no matter you are using serverless or regular APIs, so that is not a typical glitch. Rather, you have to write your code in such a way so that all your functions or whatever you are writing, that should relate to a particular context. So for example, if you're creating some certain functions, say like serverless AWS Node.js DynamoDB project, so this project defines that okay, this particular project is using Node DynamoDB altogether. Probably one of the function is not using DynamoDB, using some cache or using something get data, the same context. So that's how you define your functions. So one of the
Okay.
functions shouldn't call altogether a different ecosystem altogether. For example, order service, it shouldn't represent that. All right.
Okay. 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 Yeah. Yeah. Got it.
Okay.
Thank you.
Yep. So like if I write serverless, like how I can deploy basically. If I write serverless deploy, so it's basically packages your entire code and deploy it to your particular AWS account. And I'll be explaining you how we can map that account. If I'm not too wrong, I think I've already deployed that once. So let me check my AWS console. So I'll be showing that using AWS here because I have an active subscription on it with AWS right now. But you can try with any other cloud provider that you have. So you can use Azure Functions, or, I mean Azure or GCP. You can try with them, and let me know via Twitter. It's taking some time from my end. It's a slow internet connection. So you can see, so one, like you asked a question. So when it's packaging, basically, it excludes the development dependencies. That means if you look at your package JSON, you've seen that there's a thing called dev dependencies. So it won't be including those in the particular package file, which it will be building to deploy it in the AWS container. All right.
Okay. Okay.
So Abhishek, if it
Sorry.
excludes the dev dependencies, so how our source code will run without those external dependencies?
So no, not necessarily for your. So basically, see, serverless offline, you don't really have to run your serverless offline as your dev dependencies, right? I mean, you don't really need the serverless offline dev dependency in your actual ecosystem. So like when you deploy your Azure, I mean, Lambda functions to your AWS account, you don't really have a serverless offline plugin over there. So why to install that? Why to include that in the package? There is no point, right? All right. But if you feel that, okay, some of the plugin that is needed over there as your, I'll say what, as your dependencies. So you mentioned there was a dependency in your package.json. You don't mention there's a dev dependencies. So when you do a dev dependency, basically you mention --save-dev in your npm install command. So that mentions the npm package saying that, hey, I need this package as a dev dependency, not as a typical dependency. So based on that, you do the segregation. All right.
Why we mark AWS SDK as a dev dependency? So I think it's a framework to communicate with the AWS services using the SDK.
I cannot hear you, Prakash. Prakash, I cannot hear you. You've said something, I believe.
Prakash, could you repeat the question? I guess he's gotten on mute because of some ambient noise. Maybe he'll ask that question again.
Yeah,
Prakash, are you there?
Yeah. My apologies. So I hope I'm audible.
Yeah.
Yeah. So
Yeah, you
my
are
question was about why we mark the AWS SDK as a dev dependencies. Is it?
Yeah. So basically, so SDK stand for your software development kit, right? So that means like you need some certain SDK functions. So for example, if you go to this code, okay, just a moment. So here, just a moment. So see, to run this function actually, so serverless runs this function, but when it creates the entire ecosystem locally, so it basically using some of the AWS features in its local box, right? Now,
yeah. So let's emulate to the DynamoDB.
Yeah, so you have already available instance of the DynamoDB in your AWS actual account. So why do you need that particular SDK feature in your AWS box? Because when you're deploying that particular functions to the Lambda containers, then AWS has in place already. So why do you need that particular dependency in over there?
So SDK,
Right.
SDK that means software development kit, and it will
Yeah.
give me the wrapper functions. That means, let's say DynamoDB.connect, let's say, for example.
Yeah. So
That function
DynamoDB
I
connect.
can, that function will
So
be used into the my code. So I think that that code need to be
AWS SDK
available
doesn't
at the runtime as well.
AWS SDK doesn't really provide you that particular features actually. SDK provide you more of a different feature. Like if I go to create service, when I'm using this AWS document DynamoDB or document client, so it's the AWS SDK that is needed. But
Yes,
of
yes,
course,
yes. Perfect. So
this
is it
particular
really a dev dependency or runtime dependency?
is more like how you define, because when you are into the AWS ecosystem for this particular SDK, you don't really need that. So AWS does provide you. So think of like as a functions, not as a virtual machine actually. So on virtual machines, you have to install all your dependencies that are there. So like even if you're using some of the .NET Core related package, then also you have to install the .NET Core specifically into the virtual machines. But here in the serverless ecosystems, if you're using some standard AWS packages like AWS SDK or AWS Kinesis based packages actually, then you don't have to install them again in your serverless containers, because you are not actually deploying anything in your particular container. Rather, you are pushing that to the AWS's own containers, and it does already provide you all those dependencies. Okay, so that are been used, that can be or that has been used in AWS framework premises. So like if you go to package JSON, you can see that super test is not really part of AWS. It's more of like a test framework. So that's why it's part of the dependencies. But AWS SDK is part of AWS. So when you are deploying your actual application to the that means to the AWS cloud Lambda containers, then you don't need to have those dependencies again installed from the npm. It's already present over there. So that is what.
Okay, so you mean that AWS and these dependencies are already provided by the
Yes.
AWS
Yes.
ecosystem
Right.
into that Lambda environment.
Yes.
That's why we are not required.
Absolutely. Absolutely.
Okay, thank you.
Yep. Okay, so like I ran the serverless command. So after like the serverless deploy, so it's packaged the service and deployed the service, and then basically it gives you the particular put, post, get commands. Okay, this particular endpoints basically. So if I go to the AWS account and if I search for Lambda, actually my internet is very slow today. So it's taking a huge time altogether.
So you can share that like how we will pair AWS account with serverless framework.
Mm-hmm. Yeah, so there's a very simple command. So you have to install AWS CLI on your local box, first of all. So you can Google for AWS CLI. Comes as an installer or DMG package for your operating system. So if you're onto Windows, it will give you an installer. And once you install that, then if you run this thing, so I don't really have installed, I believe. Okay. I don't know what is happening, but it should work. Anyways, so next, you basically, when you write that, then you have to put your configuration using the serverless CLI as well. So let me show you the command. Now, in serverless is a config credentials and provider. Then for your particular cloud medium. So provider is basically you mentioning that what is the cloud provider that you are using. So since we are using AWS, so you are using, we're adding AWS over here. Then you provide the key. So how you can get the key and secret? Again, I have to go to serverless. So before that, let's already loaded. So you can see that I have deployed all these three functions. I mean 5 functions rather. So I have this dev update, I have this dynamically create, I have this delete, I have this list and get. So all these functions are deployed. So if I click one of them, and if I go over here, and let me open another tab. Loading. So so you can see that. So my CloudFront stack ID, the particular all the information that are related to the particular Lambda is already added over here. You can add an API gateway trigger if you want to have it. You can do it from here, or you can do it from the serverless file itself. Next, the environment variable that I have added over there. So you can see that environment variable values are already placed over here. So you, in a typical enterprise level project, you of course have environment variables, right? So a lot of variables that are actually varies based on the particular environment. So like if you have, if you're onto a development environment, you have certain environment variables like your database connection strings or maybe some other application secrets. And then again, if you're going to another layer up, so like staging or UAT, then you have a different application secrets and different connection strings. So you usually manage it as a CI/CD pipeline. So in the serverless, actually, you can do the same thing. So if I go back to the code, and here in the environment, actually, not this project. Yeah. So in this environment, actually, if we tell the particular serverless YAML file to say that, hey, this particular file should be placed, should be picked up from the particular CI/CD pipeline. So what you basically do, you basically remove the self part and you write the particular CI/CD pipeline name. So I cannot really demonstrate that in here, but if you can go for a CI/CD pipeline like Jenkins or Circle CI, then basically you can put this particular value, something like that. Say like I put a variable name, something like this, variable dev underscore env underscore variable, something like that. And this particular value has to be declared in your CI/CD pipeline secret. In environment variable column. So if you add this particular variable name and if you set the value of the particular variable in for the particular environment, then it will be replaced with the particular value that you give in the CI/CD pipeline. Okay. So this is how basically you manage the deployment pipeline process. So technically, you are no longer dependent on a particular environment. So you can have a single serverless YAML file, and then you call it through a Jenkins or Circle CI pipeline, and then basically you pick the environment variable from your pipeline and you set it up in the serverless YAML, and then you build. You basically run the command like I did, SLS deploy. Then basically based on that particular environment variable that you set up for your YAML file, it will be created and it will deploy to that particular environment. So that's quite straightforward. You no longer have to go in the console, AWS console, and you write your stuff. So this is one of the most advantages for using serverless. Yeah, so this is pretty much it. And yeah, I'll be showing you how to create the IAM user. So if you go to serverless, then you use IAM as a management access role, and this basically takes you to another screen.
Hey, Avishek, Shovan here again.
Yeah. Yeah.
Yeah, so until that loads, like I have some questions.
Yeah.
Okay, so
Sure.
let's say you have like 5 different functions, right? So is there a
Yep.
way like I can deploy like only one or only two from that list of 5? Or
So
whenever I
basically,
need
when
to
you
deploy, yeah.
yeah, so technically when you do that using SLS deploy generic command, then basically you cannot really do that, but of course you can pass parameters in the function name. So here in the SLS deploy actually, uh, serverless deploy, then you can pass a particular function name. Okay, then the particular function name. So what is the function name in here? It's something like this. So you basically pass create. This is a function name. Pass create. Okay, and you basically can deploy deploy the particular function. So this particular statement will get invoked, and we will be deploying your create function only. So that segregation can be done. But again, if you are onto a CI/CD pipeline, then this kind of command will be too much, too difficult to handle by yourself. But what SLS deploy does basically, it basically looks after that what are the files has been changed. So for example, if you are changing some formats in the create endpoint, and all the changes are related to that, then only create functions will be deployed. All right. So if you do some modifications in the create endpoint here, say like you remove this particular string to double quotes, and all right, and then basically you run the SLS deploy command without using this flag. Then also it will be deploying only your create.js. It won't be deploying your other endpoint like delete or get or list.js. It won't be deploying that. Okay. So either you do it manually, because uh, in your actual project, you won't be writing that code from your terminal. You basically have a pipeline in place who will be executing that. Now, how are you going to tell your pipeline that, okay, this particular function has to be deployed? Then you need an interactive pipeline. But if you have more of a commit based, like Git based pipeline, like whenever some Git event happens, like push or commit happens, then you basically deploy the particular change set to the particular environment. Then you cannot really handle that. So that's why serverless deploy does it automatically. It basically checks the particular endpoints which has been impacted or only those functions, to be precise. Does that answer your question, someone?
Yeah.
Okay, cool.
Thanks.
Okay. Yeah. So this is the IAM user role. Okay, and here you can see that basically I have a user. If I click on that user, I have a serverless user, and I can give some permissions. Basically, I can give the security credentials. So the security credentials are basically your access ID and the secret. Okay. So if you click on that, and or rather if you create access key, then basically it will be giving you all those secret key and the access key. Now, if I go back to the command, if I see that, it basically asks you the key and the secret. So you can see that if I go back to the UI browser again, it's giving you the access key and the secret. So basically you have to pass this two particular information in this command, and then you technically set up your particular profile or your AWS account with serverless. Now, whenever you do some deployment, basically you have that particular user in place who does the deployment for you. Why is that? You cannot really give a particular user account name. Like for example, you are a root user and you don't really want to give access of the root user to the serverless configuration. So rather you want to give what your particular serverless user having some limited permissions to your AWS account, and that user will be deploying all your artifacts to the Lambda. Then you can actually create that user and then you can get the particular secrets and the token or the key from AWS console, and you create that user or set that user into serverless using this command. All right, and that solves your problem. So basically, after you set up, basically, whenever you run that serverless command, like create or like serverless offline commands, whatever. So basically, so serverless offline is not necessarily using this AWS credentials, but mostly create. Then basically, or SLS deploy technically, then all these commands will be using this particular provider, AWS, and the particular secrets. And of course, you can provide something like that dash name and a particular profile name. So if you don't provide any profile name, it will be default by default name. So if you, when you're creating a particular project template, after that you can use something like that, profile and the profile name. So like use my Azure profile, something like that. Use my Azure profile. So that means it won't be using a Node.js, I mean AWS account anymore. So it will be using the Azure profile that you have already set up using this command, but you have to give the name of the particular profile when you're setting up. So with serverless, actually, you can have multiple profiles set up. So you are using AWS, probably you have a personal AWS account, you have an official AWS account, you have a Azure account, you have another GCP account, and probably you'll be doing all those projects together, and you have to set up your project for individual cloud provider. So for that, you have to pass this profile command when you're creating a particular template. And after that, serverless will be referring, whenever you are running SLS deploy command, serverless will be referring to that particular profile which you have mentioned during the creation of the project, and will be using that profile only. So this is very straightforward. Any other questions on that?
I have a question, but not on those lines. Suppose we are done with the deployment. Let's say we move
Your voice is
and
breaking,
go through the
Ashish.
CI pipeline. Yeah.
Ashish, your voice is breaking. Could you repeat the question, or maybe put the question on chat, because your voice is breaking?
Yeah, I'll try to repeat. I'll try to repeat. If it doesn't work, I'll type again.
Yeah.
So I'm saying, what if I have to do some kind of integration testing post deployment on some cloud provider of what the check-in has been done through some automation?
It's cannot be a scope of the serverless at all. It can be anything. So of course, like whenever you talking about integration testing, then you can set it up during your CI/CD pipeline process. So like during your deployment process, you can have integration test codes to be run that has been deployed, and you can check into the particular, probably that can be your automation test as well, or maybe some kind of API endpoint test. So those codes can be run. And integration tests totally depend on which particular language that you're using. Of course, with serverless, you can use it. So like I said, it's basically part of the deployment pipeline. So you won't be doing it in your local box. And even if you can do, of course, in your local box, but technically in an ideal way, you should be running an integration test in your deployment pipeline process to ensure that, so probably like your API is interacting with some other API projects, and you want to ensure that none of the APIs got broke. So you don't really have all the API projects in your local box, right? So of course you cannot run the integration test in your local box. So you set that up on your Jenkins or Circle CI pipeline technically, and then during that deployment process, actually you'll invoke those particular test cases from Jenkins profile, and if one of them is failed, you do the required action. That is what. Now in terms of tech stack, that what kind of technology you can use. So with Node.js, of course, you can use Supertest. That's a good option for the integration test. And with C#, you can use MS Test as a framework, and of course, you can use Crystal as a test server. Because Node is also providing a server which can be used a Node server for testing, or Express server basically. So that's what. I'm not really familiar to any other technology that I can help you out. But of course, you can use this kind of steps to integrate your integration test.
Thank you for your answer. And by the way, I'm also from the Microsoft stack, so I can understand what you're saying.
Okay, great. Okay.
Thanks.
Yeah. I think I'm pretty much covered. Yeah. So that's it basically. So we are on time. So yeah.
Any other questions that you guys have on the session or on the topic as of now? So if there's no question, can you also probably, those who have participated in this, could you also share some feedback about the session as well? Maybe initial impressions of how the session went, and of course we would want to take your feedback, a more detailed feedback on the meetup page itself. We'd be very happy to get some feedback, constructive feedback, which could help us in future sessions. But maybe anyone want to share some initial impressions of the session itself? How did it feel for you guys? Okay. All right. So that's okay. So please feel free to share the feedback of this particular session on the meetup page. As I said, we have recorded this particular session and it will be available on our YouTube page. The YouTube link, I'll share on the meetup page as well. All right. Thanks everyone for participating. We'll be doing a similar Technovise session in the coming month as well.
Yep.
Anayanka, you were saying something?
Yes, sorry, I was on mute. So just wanted to say a very fantastic session, Avishek and Mayank both. So Avishek especially. It was really nice. I mean, it is something really new for me. I am aware of serverless framework, but this generic serverless framework is something which I was not aware of.
Okay. All right. Thanks a lot.
So it was also a nice session for me. Like I get to know like what is serverless framework and all. So thanks Abhishek and Mayank.
Okay.
Thank you, Arpit.
Thanks again. We will be, as I mentioned, we'll be sharing the YouTube link pretty soon of this recorded session. And on the meetup page, we'll also be putting the PPT that Avishek had created. Yeah. All right. Thank you so much. Yeah.
Thanks everyone. It was really nice learning here.
Thank you guys. Thanks for the time. Bye-bye.
Bye.
Bye.